Hello, in this particular video, I will show you how to run a neural network using XLMiner. So first you load the file. Just make sure that the data set is free from any seasonality. In this particular case, I have loaded the Amtrak file I have used in the class, and we considered a monthly seasonality. In other words, January to January, there is some kind of an effect. So to control for those kind of seasonal components, I have created the 12 lags, lag 1 to lag 12. What this lag means is lag 1 means the value in the previous time period. So if you look at lag 1 for February 1992, it is the value which was in January 1992. If you look at lag 2 in March of 1992, which is nothing but the value of January of 1992. So the first thing we will do, and given this is a time series database, a data set, in other words, it is based on a certain time period, and there is a data on observation at every given time period. So to forecast in a time series, first you will do is we will partition the data. Partitioning means we're going to decide how many of these observations will be the part of our training set and how many of the observations will be part of our validation set. Training set is used to train our neural network. In other words, we use this information to make the system learn about the different trends in the data set, and the validation set is used to validate or to test whether our forecasting is doing as it's supposed to do. So in partition, we will click on the partition tab under time series cluster, and after we click on partition, we want to make sure that the name data set on the worksheet is exactly the one you are currently using. Although it does not matter at this time, given this is the only thing that is open, but later on, if you want to actually have multiple spreadsheets open at the same time, it sometimes get convoluted. So you have this data, then you have to identify what is your time variable. In this case, month is the time variable. So you select month and you go to and assign it to time variable. And then you have to select the variables which will be a part of your partition. So in our case, we will select all the rest of the variables. So what I will do is I will select the ridership and then I will press the shift button and click on lag 12. In this way, I select all the variables which are under the window variables and move them to the window saying variables in the partition data. After that, there are two ways of partitioning our data. We can use percentages or you can specify records. For this particular exercise, let's consider that we specify number of records and we consider, for example, I'll click on the specify records and I will consider that I'm going to have, let's say, 12 I'm going to have 135 in the training set, and then 135 observation in the training set, and then 12 in the validation set. So what I will do is I will click on specify records, number of records. Then I'll click on specify number of records under this particular window, and then we will say 135 in the training set and the 12 in the validation. So you just click on this particular window and you can change the value, and as you change the training set, automatically validation set will also change, and you click OK. As you click OK, a second spreadsheet will come up and you will see something like this. And if you click on these tabs on the top, training data, it will highlight the data set which was already in data 1, which is a part of your training set, and also validation, which is the last 12 values or observation. So now we are ready to run our neural network. So we have a training set and the validation set. And now we are going to use this particular spreadsheet called data partition TS as our way to do our prediction model. So now we were going to click on predict, which is under data mining. And then we have something called neural network. In our case, since we are learning at this time, we're going to create something called a manual network. So let's click on that, and you will see something like this, where you want to make sure that this data set worksheet is indicating the partitioned data, and then you have 12 as validation and training as 135. Your output is ridership, right? That's what you want to predict. And your selected variables will be your lag 1s to lag 12. Okay. Make a note that time variable, we can also select time variable as a part of it, or we don't have to, but in this case, let's select it. In this way, time is a part of it. Now, it depends upon your model. For some model, people say, okay, I have captured components of time with the lag variables. So in that case, we don't have to include the time component. On the other hand, some people will say, well, it's a part of the model. So depends upon, what is your model looks like, or you consider you can have them. But in our case, we're going to have the time along with the lag variables under the selected variables window. Now, this is our independent variables. So selected variables are our input nodes into our neural network. And the output variable, the ridership, is the only output node we are looking at. So currently we have 13 input nodes and we have one output node. So the next thing is to consider how many hidden layers you want to have. And so what we can do is we can have a maximum in this particular program. We can have maximum 4 layers, and each layer we can have n number of nodes. For our exercise, I'll keep it as is this. You can also change the seed, initialization seed. The idea is to, if you as you know, in our computers we have different timers in the CPU, and therefore if we do not set a seed every time we run a program, especially like neural networks, we might get different types of result. So to make sure that we maintain the same results throughout our multiple exercises, we want to set the seed here. Number of epochs will tell you how many times you want to run this whole process. Then we have the error tolerance level. So if the error of the overall output is below this particular level, it's going to stop. Weight decay, we'll talk about that in the class, talking about creating a momentum. And weight change momentum is also there to avoid any kind of local minima or local maxima problem. Then we can use looking at how many nodes we have. So in this particular window, I'm going to just select, we want only one hidden layer with 25 nodes. As I discussed in class, if you have more nodes and more layers, chances are you're going to overfit. So it might work great as an output for this particular exercise, but there is not much practical value when you have a large number of nodes in it. Then I'm going to click next. Okay, I'm going to click on detailed reports here under score training data, and then score validation will be detailed report. And then I can say, well, I'm going to create the score in a new sheet. Okay, and I click on that. Now, depends upon what we're doing it, we can select this. But since our exercise is just to make sure that I want to train and validate, I don't want to select this particular worksheet. Same thing, we can actually select the in database, where you can actually take the output of this particular exercise back to a particular database. So you select these four things, make sure detailed reports and summary report is selected under score training data and score validation data, and you click finish. And what you will see here is you will see some new outputs. So there will be an NNP, in neural network program output, NNP training score, NNP validation, NNP train log, okay, and then NNP stored. Okay, so there are quite a few, a new spreadsheet will come up. So what we will be looking for is, let's say, look at how the training occurred. So what I will do is I'll click on the NNP training score, and I will select predicted values and actual values. After I select this, only the whole data set, please do not select the columns. Just drag and drop your cursor to select the data set, and then I want to go to insert, and then I want to click create a line chart. So in this particular case, as you can see, here's our data set looks like. And so it did pretty good. I mean, our line chart of our training set says that the neural network actually did fit a good line across the actual value. So this shows that your neural network did a decent job with fitting the data to your training set. The next thing to really look for is the validation. So how well did it predict? So what it happens is in this validation set, data is not observed by the neural network. So it's like all these this data, which is under actual value, are actually then as if it's new to the neural network. So I will click on select this and see how it performed, and looks like it did pretty good actually. I mean, you can look at the data set and also the predicted value and the actual value. They actually follow each other very close. So once again, this is a video of how to really run a neural network to predict a time series.